Hi there, welcome to the channel, and today we will be solving series and parallel circuits using Ohm's law, and we will be also using series and parallel circuit formulas to help us solve these problems. So I'll just start the video by covering why Ohm's law is important and how to derive it and how to easily remember it. Ohm's law states that the electric current through a conductor between 2 points is directly proportional to the voltage across the 2 points, and you can characterize it with this formula, V equals I times R. And you can rearrange it for current or resistance like so. So let's say we want the current, divide the resistance on two sides, R divided by R will cancel out, and you're left with V over R equals I, like that. And same case for the resistance. Say you want the resistance, V over I. Easy way to remember this formula, you can say Ohm's law triangle can be used for this. V, I, and R. And V at the top is important. So let's say you want the voltage. Put your thumb over the top. What's left is I times R. And let's say you want the current. Put your thumb over it. And what's left is V over R. Easy. Seeing that resistance is a key part of Ohm's law, it can come in two flavors for circuit analysis: series and parallel. So for the case of a series connection of resistors, the equivalent resistance of series resistors may be summed up like so. It's just a simple case of R1 plus R2 plus however many resistors there are. And for the case of a parallel connection of resistors, may be summed up like this: 1 over RT, the total resistance, is equal to 1 over R1 plus 1 over R2 plus however many there are. And there is actually another method to solve parallel connections, and that's product over sum. So let's say there are two parallel resistors. You could also solve it like this: product of R1 and R2 over the sum of R1 and R2. So before we start solving circuit problems, we need to first understand the components that make up a circuit. In this video, our circuit problems will only involve voltage sources and resistors. So let's draw some and see how they work. Let's start by drawing our voltage source. It has a positive and negative side, and it has some value measured in volts. Let's say this voltage source has 12 volts, and a wire comes from the positive terminal of this voltage source and connects to a resistor. Let's call it R1. And now what a resistor does is it resists the flow of current. That's where it gets its name, and it can be measured in ohms. So let's say this resistor has a value of 6 ohms. Now what do I mean by current? Well, I'll tell you, current is what carries the voltage. It's what makes the voltage flow through a circuit. That's what it calls current. And in circuit analysis, we look at the conventional current flow, characterized here, and I'll draw it again. So the flow of conventional current flows from a positive potential to a negative potential, as seen here. It will flow from this positive potential, positive terminal, should I say, of the voltage source, and when the circuit is fully drawn, I will show you that it goes back to the negative end of the voltage source. Now let's have a closer look at resistors. They can be connected in series and parallel, previously discussed. So let's have a look at a series connection. That's a series connection. R2 and R1 are connected in series. Now let's take a look at a parallel connection. Let's add one here, and let's call it R3. How would you be able to tell that these resistors R2 and R3 are connected in parallel? Let's draw some positive and negative ends of these resistors to help you visualize it. So one way to look at a parallel connection, as well as just having them parallel next to each other like this, is to look at the way they connect. So they connect at the same terminal here. Both positive sides connect at the same terminal here. And look at the negative sides of R2 and R3. They connect here. It might not be straight away obvious because of the way it's been drawn, but they do connect here by means of current at this wire, at this terminal here. And just to help you visualize the flow of conventional current, I will finish drawing the arrows. It will flow across each resistor and through the wires. And it will flow back into the negative terminal of the voltage source. With that said, I think we're ready to solve some problems. Let's start with the basics and consider this circuit. And you need to find the total resistance, the current flowing through the circuit, and what is the voltage drop across each resistor. Pause the video if you need to and work on the solution. Now let's solve the problem. The first step is to sum up the total resistance. These resistors are connected in series, and therefore 3 plus 2 equals 5 ohms. Now we have the total equivalent resistance. We can use Ohm's law in the form of I equals V over R to find the total current flowing through the circuit. So in this case, 10 divided by 5 is 2 amps. Now let's work on the problem of what is the voltage drop across each resistor. Now let's use Ohm's law once again. V equals I times R. And let's start with the first resistor. 3 ohms times 2 amps equals 6 volt drop. And then let's work on the next resistor. 2 times 2 is 4 volts. And that's the problem solved. Let's change things up and consider this circuit. What I want you to do is to find the equivalent total resistance and what is the total current flowing through this circuit. Take your time if you need to and pause the video. Let's start by summing up the two connections, R3 and R4, since they are in series. It's a simple case of addition. 3 plus 3 is 6 ohms. Now this equivalent resistance, in the case of this circuit, is in parallel with the R2 resistor 5 ohms. Now, there are two methods to solve parallel resistor connections. We can start by using product over sum, which is 6 plus 5, the product, over 6 plus 5, the sum. Now using this, the answer here for the equivalent resistance of parallel connection is 2.72 ohms. Now the other method is to call back onto the parallel resistance formula, which is this, 1 over RT equals 1 over R1 plus 1 over R2, etc. By raising both sides to the power of -1, that's the way to add up multiple parallel resistors. Now, in this case, we just have two parallel resistors, so you're better off using this, product over sum. It's much faster than doing this. But in the case of where you have multiple resistors, say 3 or 4 parallel resistors, you're better off using this formula here, because in product over sum, you can only do 2 parallel resistors at a time. And this one, you can just do it all at once, and you'd get the answer. Anyway, now we have the equivalent resistance here. It's now in series with the 4 ohm resistor R1. So let's solve it. So it's just another case of addition here. 4 plus 2.72 is 6.72 ohms, which is your RT, total resistance of the circuit. Now, the other problem is to find the total current. So it's easy from here. It's just I equals V over R. Therefore, 6 over 6.72 will give you an answer of 0.89 amps, which is your answers here to solve this problem. This is the last problem I'll be covering in this video. What I want you to do in this scenario is to calculate the total resistance and what is the total current flowing through this circuit. Pause the video if you need to and take your time. To start solving this problem, I would first sum up the two series resistors here, 4 ohms and 6 ohms, that's 10 ohms. Then take a closer look. Remember what I said about the positive and negative ends? The positive ends are here for these three resistors, and negative end for this resistor is here. And see that what they all have in common? The negative end meets on this wire. So therefore there are three resistors in parallel. And calling on from the previous solution, I would use this formula to sum up the parallel resistors. Which gives you an answer of 3.53 ohms. Now just to show you that product over sum works as well, but just keep in mind that product over sum works for two parallel resistors at a time. So let's start by going this way. 12 times 10 over 12 plus 10 is 5.45 ohms. Rounded to 2 decimal places, by the way. So that's the equivalent parallel resistance of these two resistors in parallel. We still have, this is still in parallel with that 10 ohm resistor. So we do it this way again, product over sum. Which will give you the same answer here, 3.53 ohms. Now, this resistance here is the equivalent impedance of all these four resistors here, or rather resistance I should say in this case. And it's now in series with this 5 ohm resistor. So we just add 5 ohms to 3.53, that's 8.53 ohms. And that is your equivalent total resistance of this circuit. Now to get the current flowing through this circuit, once again, is just a matter of I equals V over R. 12 over this equivalent resistance, 8.53, is equal to 1.406 amps. Rather 1.41 amps rounded to 2 decimal places, and that is the solution for this circuit. So yeah, that's the end of this video. Thank you for watching, I hope you enjoyed, and let me know in the comments what you think and what videos you would like to see in the future related to electronics.